class. Our activity for today will be about the rectifier circuit. We have here a diagram showing the primary circuit of the transformer, and we have the secondary circuit. The difference between the two is that the primary circuit is the one that is connected to your AC source, and then from the primary circuit there will be this what we call electromagnetic induction. As you see, there is no electrical connection between the two windings, and so that is the important part of the important principles being followed here in rectifier circuit. On the opposite, on the secondary side, we have these different components. We have the diode, we have the inductance, and we have the resistors and capacitors. So this part, on the upper part, is the half wave. We call this half wave. You see, class, the difference between AC and DC circuit is that the AC circuit, this is a continuous alternate cycle of current flow from zero to maximum positive maximum voltage down to zero, back to negative, and then back to zero. So in here, it is shown by the symbols. This is the symbol for an AC circuit, and this is your DC part. What is important here, class, is we will later on you will discover that in this circuit, despite of 220 volts AC, we can produce different voltages on the output side of this rectifier circuit. And then the next activity that will be discussed is the full wave. This one is the half wave. This is the half wave, and this is the full wave. In the half wave, we use only one diode. And on the full wave, we use a rectifier bridge wherein composed of 4 different diodes. Between the two, it is more acceptable and more useful to use this full wave rectifier, because of the signal on the output side. There is that what we call this current will move faster in this circuit compared to this one. As you see, here there is a gap, and here there is no gap between the cycle or between the movements of the current. And then we have here the capacitor. The purpose of the capacitor is to filter the current from pulsating current to pure DC. That is what we call ripple current. Later on in our lecture, I will explain to you what is the formula for ripple current, for load resistance, and for determining the value of this capacitance. Any question, class? The first activity that I will present to you, or I will demonstrate to you, is about the connection of three-phase transformers. You see, in this diagram, we have 3 sets of single-phase transformers. As you notice, in our previous discussion, these 3 single-phase transformers has been checked for its correct polarity. So, make sure that all of you are familiarized with the polarity testing of each transformer before we proceed with the connections of these three single-phase transformer into one single three-phase transformer. Okay, to review, for the polarity, this dot represents your H1. So for the primary winding of the transformer, you mark it H1, H2. H1, H2. H1, H2, H1, H2. So you have your three single-phase transformer. All primary windings of this transformer are marked H1, H2. And when we go to the secondary side, it will be different. If you have found, you have discovered that transformer polarity is additive, it will be X2, X1. You use X. X2, X1, X2, X1, X2, X1. If it is subtractive, X1, the first is the one terminal will be X1 and the other two terminals X2. So here, we will now proceed with the first connections. The first connections that I will discuss to you class is the star connection. Okay? Then later on, I will discuss to you delta connection. That's all. I will explain to you the detailed discussion of that when we deal with that on the activities on the practical side. But for the meantime, since I'm just giving you the briefing, that's all. I think that's all for today.